Welcome back, student. Today we are going to have brainstorming over Joules law of heating. My dear student, here I have drawn a circuit diagram. The diagrammatic representation of various components in a diagram is called as electric circuit diagram. My dear student, we have connected different electrical components in a circuit and I have drawn a circuit diagram. My dear student, we are studying Joules law of heating. In this circuit diagram, my dear student, I have connected a potential difference to a conducting wire. The potential difference is a cell. My dear student, in this diagram, this is the diagram or symbol of a cell. My dear student, you know that the cell consists of two terminals, positive terminal and negative terminal. The positive terminal is said to be at high potential and the negative terminal is said to be at low potential. My dear student, this line with a greater length is denoted as positive terminal and the line with a smaller length is said to be as a negative terminal. My dear student, in this diagram, I have shown a cell connected to the conducting wire. We have also taken resistance, and this is the resistance connected in a circuit, or this is the resistance which is connected in a connecting wire. We have also taken voltmeter. My dear student, we have also taken ammeter. We have also put a key to make the circuit open and close. My dear student, here we have connected voltmeter and the voltmeter is connected parallel to the resistor. The voltmeter measures the potential difference between the two ends of the resistor. Here A and B are the two ends of the resistance and the potential difference between point A and point B will be measured by voltmeter. The positive terminal of the voltmeter and the positive terminal of the cell, the negative terminal of the voltmeter and the negative terminal of the cell is carefully marked. My dear student, when a potential difference is connected in the conducting wire, there is flow of current and the current is measured by ammeter. My dear student, I have correctly connected ammeter in a series. The positive terminal of ammeter and the positive terminal of the cell, the negative terminal of the ammeter and the negative terminal of the cell is correctly marked. My dear student, we are studying Joules law of heating. Connect various components in a circuit as shown in circuit diagram. My dear student, we have taken a connecting wire. To this connecting wire, we have connected a cell. We have also connected the resistance in a conducting wire. We have also connected voltmeter. We have also connected ammeter. My dear student, we all know that when a potential difference is applied to a conductor, then the electrons start moving to a particular direction. My dear student, electrons are negatively charged and they start moving towards the positive terminal. Therefore, my dear student, when a potential difference is connected to a conducting wire, then there is flow of electron from the low potential end to the high potential end. This we have studied in 9th standard. But according to the convention current, we say that the current always flow from high potential to low potential. So, my dear student, one thing we know very well, that the direction of flow of electron and the direction of convention current is opposite to each another. And here, my dear student, the current flows from the high potential or from the positive terminal towards the low potential towards the negative terminal, and I have marked the direction of flow of current in a circuit diagram. My dear student, we are going to study the heating effect when the current is passed through the circuit. My dear student, here we are going to consider point A and point B. The potential difference between the point A and point B will be measured by voltmeter, and the current passing through the circuit or the current passing through the circuit will be measured by ammeter. My dear student, here point A is considered to be at high potential. Why point A is considered to be at high potential? Because point A is connected to the positive end of a cell. My dear student, here point B is considered to be at low potential. Here point B is said to be at low potential because it is connected to the negative terminal of the cell. My dear student, now we are ready to prove Joules' law of heating. My dear student, here we know that when a potential difference is connected to the conducting wire, there is displacement of electrons, and the displacement of the electrons takes place from the low potential end towards the high potential end. Means electrons being negatively charged, they start moving towards the positive terminal of the cell. So there is displacement of electron. My dear student, do you know displacement? Yes, we have studied displacement. Is displacement related to any terminology in physics? Yes. Displacement is related to work. When force is applied and there is displacement, we say that work has taken place. So as there is displacement of electron, we can say that work is done. My dear student, when the current is passed through the circuit, there is displacement, okay, of electron. Or my dear student, when the potential difference is applied to a conducting wire, then there is a displacement of electron. When there is a displacement, we can say work is done. Now my dear student, is work related to any terminology in physics? Yes, work is related to energy. How work is related to energy? The capacity to do work is called as energy. Oh, now we have introduced one more terminology of the physics, that is energy. My dear student, is energy related to any terminology which you know in physics? Yes, it is related to power. My dear student, when there is a displacement of electron, we say that the work is done. The capacity to do work is energy. So energy also plays an important role. The rate at which work is done is said to be power. So power also comes in the process. So work, energy and power are related to each other. So we consider work, energy and power to prove Joules' law of heating. My dear student, here energy. Do you know any terminology related energy? Energy, heat. Heat is also a form of energy. My dear student, when we connect
potential difference to a conducting wire, then there is displacement of electron. When displacement of electron takes place, we say that the work is done. The capacity to do work is called energy. So the amount of work done will be equal to energy. The rate at which work is done is said to be power. So energy will be equal to power. One more form of energy we have studied, that is energy is also heat. And my dear student, we are trying to explain or try to learn heating effect in a conductor, and therefore heat as a form of energy we will also consider. So all these terminologies are related to Joule's law of heating, and we have to understand each and every terminology carefully. My dear student, in 9th standard you have also studied law of conservation of energy. According to the law of conservation of energy, energy cannot be created, cannot be destroyed, but the total amount of energy remains the same. So here, according to law of conservation of energy, power will be equal to energy, energy will be equal to work, and work will be equal to heat. So my dear student, all these terminology will be equal to each another according to the law of conservation of energy. Energy cannot be created, cannot be destroyed, but the amount of energy in the universe will always remain constant. So my dear student, when the current is passed through the circuit, work is done, work is equal to energy, energy equals to power, and power will be equal to heat. We are studying Joule's law of heating. My dear student, according to law of conservation of energy, energy cannot be created, cannot be destroyed, and the amount of energy in the universe will be constant. So my dear student, according to law of conservation of energy, we can say that the energy cannot be created, cannot be destroyed, but the total amount of energy in the universe will be constant. My dear student, here there is displacement of electron, work is done. The capacity to do work is energy, so work is related to energy and work will be equal to energy. The rate at which work done is power, so energy will be equal to power, and energy is a form of heat also, so we will consider heat in this example because we are studying Joule's law of heating. My dear student, before going further in our topic Joule's law of heating, we will try to know some terminologies which we have studied in the lower classes. First, current. Charges passing through conductor in unit time is called as current. Current is denoted by I, and the formula for current is I is equal to Q by T. Potential difference. The amount of work done to carry a unit positive charge from point A to point B is called as potential difference between the point, and potential difference is denoted by V, and the formula is V is equal to W by Q. My dear student, here we have written VAB, means we are going to consider the potential difference between point AB. So VAB is equal to WAB upon Q. Q is the charges. My dear student, from this definition of potential difference, we can find the definition of work, because here we have considered work. So work AB is equal to VAB into Q. So my dear student, from the potential difference definition and formula, we have derived the formula for work, and the formula for work is WAB is equal to VAB into Q. My dear student, the capacity to do work
The capacity of a body to do work is called as energy, and the work will be equal to energy. This we have to consider in this exam. Example: power. Power is the rate at which work is done. The rate at which the work is done is said to be power, and therefore the formula of power is P is equal to W by T. And we have also studied Ohm's law. According to Ohm's law, we can say that V is equal to IR. Now, my dear student, our concept is clear, and we also know what happens when an electric current passes through a circuit. There is displacement of electron, work is done, the amount of work done is equal to the amount of energy used. The energy is used, it will be equal to the power which is supplied, and this all will be equal to heat, because heat is also a form of energy. And according to the law of conservation of energy, energy cannot be created, cannot be destroyed, but the total amount of energy in the universe will be constant. So, using the law of conservation of energy, we will try to study Joule's law of heating. My dear student, here power, energy, work and heat will be same. Power is equal to, what is the formula of power? Power is equal to work upon time. So we will write power is equal to work, and work AB we will write upon time is equal to HEAT. My dear student, from the above concept, we have taken power. We have written the formula of power. Power is equal to work upon time, and which will be equal to heat. But my dear student, here we have to find heat. So what we'll do? We'll write the formula of heat. Heat is equal to, this heat is equal to power into time. But my dear student, again, what is power? Power, so you can write heat is equal to, what is the formula of power? Power is what? VAB upon T into T. My dear student, we have just substituted the formula of power in the equation. But here, my dear student, we have got work AB. Now we also have derived the formula for work. So we will put it in the next step. Heat is equal to work, and work is equal to what? V AB into Q upon T into T. My dear student, here if you correctly observe, Q by T represent I. Q by T represent I. So what will we do? Heat is equal to V AB, and Q by T means I, which will put into I into P. Equation 1. Now my dear student, we got equation 1. Heat is equal to V AB into I into T. My dear student, according to the Ohm's law, we say that V is equal to IR. So VAB is equal to IR. So we can put the value of VAB as IR. Heat is equal to IR
into I into T according to Ohm's law. VAB is equal to I. Now my dear student, we have got an equation. Heat is equal to IR into I into T. Heat is equal to I into I square into R into T. This is the mathematical representation of Joule's law of heating. According to Joule's law of heating, the heat produced in the conductor, my dear student, according to Joule's law of heating, the heat produced in the conductor is directly proportional to the square of the current, square of I. Resistance of conductor, R, resistance of conductor, and T, time for which the current flows, and T, the time taken for the current to flow through the circuit. My dear student, here we are studying Joule's law of heating. My dear student, if we take a conductor and apply a potential difference to a conductor, then what will happen? The current will start moving from the positive terminal to negative terminal, and the electrons will start moving from the negative terminal to positive terminal. The direction of the flow of the current and the direction of the electron will be opposite to each other. My dear student, here we know that there is displacement of electron. When there is a displacement of electron, we can say that the work is done. When work is done, we can say that work is done equal to the energy, because the capacity to do work is called as energy. The energy which is used to do work will be equal to power, because the rate at which work is done is said to be power. And my dear student, energy is also related to heat. So we can also consider heat in this example to prove Joule's law of heating. According to law of conservation of energy, energy cannot be created, cannot be destroyed, but the total amount of energy in the universe remains the same. My dear student, before going to derive the mathematical expression of Joule's law of heating, we should know certain terminology. Current. Charge passing through a conductor in a unit time is called as current, and the formula for current is I is equal to Q by T. Potential difference, the amount of work done to carry a unit positive charge from point A to point B is called as potential difference between 2 points. So potential difference is denoted by V. So VAB is equal to work upon charges. Here we are going to consider point A and B. So we are going to write A and B accordingly as shown in the on the you can say whiteboard. So here from the definition of potential difference we can also derive the definition of work, because we have considered work here. So work is equal to V into Q. The capacity of the body to perform work is called energy, and work will be equal to energy. My dear student, power. Power is the rate at which work is done, and the power can be calculated by P is equal to W by T. All this concept you have to understand properly. According to Ohm's law, we have studied V is equal to IR. That also we have to use. Then, according to the law of conservation of energy, heat, work, energy and power will be constant, same. Power is equal to heat. So power is equal to heat. But what is the formula of power? Power means what? Work upon work done, the rate at which work is done. What is power? The rate at which work is done. So the rate at which work is done we have written
in the form of the formula. So power is equal to W by T. We are going to find heat. So we will try to write the formula of heat. So we have taken heat at one side of equation and we have multiplied power into time. So heat is equal to P into T. Heat is equal to, what is the formula of power? Power is what? The rate at which work is done. So we have written the formula W by T into T. But work, the formula of work also we have derived. From what? From the potential difference. So work here we have derived, and work is equal to V into Q. So we have put here in the equation WAB upon T into T, and then we have put the formula of work, that is heat is equal to VAB into Q upon T into T. But my dear student, we also know that Q by T represents something. What does Q by T represent? Q by T represents the current. So heat is equal to VAB into I into T. Q by T is represented by I. This is equation 1. So heat is equal to VAB into I into T. But my dear student, according to the Ohm's law, VAB is equal to IR. So we will put this value in the equation. So heat is equal to IR into I into T. So according to the Ohm's law, VAB is equal to IR. So what will happen? We will get the Joules law of heating, that is heat is equal to I into I square R into T. According to the Joules law of heating, when a current is passed through the conductor, the heat produced is directly proportional to square of the current, resistance of the conductor, and the time taken for the current to flow through the circuit. So my dear student, this is Joules law of heating. I hope you have understood it. Thank you very much.